Most people think engineering mechanics problem solving is about remembering formulas and blindly plugging numbers into them. But the truth is that every mechanics problem was created to test one thing only. Can you think logically about forces in motion before touching mathematics? Long before exams existed, people were already solving these problems intuitively to build structures, lift loads, and move objects safely. To see this clearly, imagine a simple, everyday situation where you try to push a stalled car. Before you push, you instinctively check where to apply force, whether the ground has enough friction, and whether the car is likely to move or stay at rest. Without realizing it, you've already done what every engineering mechanics problem demands. You analyzed forces, constraints, and possible motion before applying effort. What's actually happening here is straightforward. Every mechanics problem follows a fixed thinking sequence. First, identify the object or system. Second, identify all the forces acting on it. Third, decide whether the object is at rest or in motion. Only after this logical setup do equations become meaningful. Engineering mechanics trains you to convert real physical situations into solvable models step by step. This same logic is exactly how exam problems are designed, whether it's a block on an inclined plane, a pulley system, a beam under load, or a particle in motion. The examiner isn't testing memory. They're testing whether you can draw the correct free body diagram, apply equilibrium or motion laws correctly, and interpret the result physically. The structured approach to mechanics problem solving comes directly from the laws formalized by Isaac Newton, whose principles made it possible to reduce complex motion and force interactions into systematic, solvable steps. Once these steps are followed correctly, even the hardest-looking problems become predictable rather than intimidating. Now that you understand how engineering mechanics problems are meant to be approached, the next natural step is to practice free body diagrams, equilibrium equations, and motion-based numericals, where we'll walk through real exam-style questions step by step, exactly how an engineer is expected to think.